Hey, Algebra 2, what's up? I hope you guys are having a great day. Okay, so today uh, we're going to talk about parent functions. And basically, these are like the 10 functions that we're going to be using throughout the year. And so you need to get really familiar with them. There are very few things that I'm going to ask you to memorize. This is one of them. Okay, there's a reason for it though. Okay, it's not just a pointless, I'm making you memorize stuff just because I think it'll be funny. Um, you'll use them later on all year long. And if you know what the original function looks like, if you know what the parent function looks like, then everything else will be so much easier for you if you're not like trying to figure out what the function looks like. Okay? So that's why I have you memorize this. Okay, so here we go. First one is the constant function. Okay, you want to assume that b is a constant, meaning it's just a number. So y equals like 3, for example. Let's sketch out y equals 3. Okay, in this case, b isn't an actual number, so I can't actually graph b, but this is the line y equals 3, right? And basically what that means is no matter what x is, if x is 1, y is 3. If x is 2, y is 3. If x is 3, y is 3. And so on and so on and so on. Okay? So a constant function, straight line. Identity function, okay? This is your basic linear function, right? So f of x equals x is the same thing as, y equals x. So when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2, right? And so on and so on. And so basically you end up with a line that cuts through the origin at a perfect 45-degree angle. So that is the function y equals x. Basic linear function, also known as the identity function, because you put a 1 in, you get a 1 out, right? So it doesn't change anything. That's why it's called the identity function. Anyways, side note, that's all. Next is the square function. Now, if you don't know what this looks like, you can make a table, right? So I'm going to start out with just a basic table until we kind of see a pattern, y equals x squared. So let's pick a -2, -1, 0, 1, 2 for our x's. -2 squared is 4, -1 squared is 1, 0, 1, 4. Okay, so if you notice, if I plot all of those points, 2, 4, -1, 1, -2, 4. Okay, we end up with this like funky smiley face looking thing. Okay, that's called a parabola. You don't need to worry about that right now. Just know that it's a square function, which makes sense, right? Because it is x squared. Next, common sense, is also the cube function. Hey, what's a cube? Well, okay, aside from the thing that a die is on, a cube is when you take something and cube it, raise it to the third power. So this is the cube function. Okay, again, maybe you don't know what that looks like. So let's make a little table. I'm going to go with more than 5 numbers. Let's go, here's x, and here's y equals x cubed. Let's go -3, -2, -1, 0, 1, 2, 3. Let's see if we can find any patterns. Okay. Now, if I take -3 and cube it, -3 times -3 is 9. Times -3 is -27. Okay, that's going to be off our graph, so we're not going to get to plot that point. -2 cubed is -2 times -2 times -2, -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Okay, so then we can plot those. 0, 0, -1, -1, -2, -8, that's like way far down there. 1, 1, 2, 8, which is way far up there. 27 isn't even close to being on our graph, so there. That is approximately what the cube function looks like. Okay? Great. Number 5, the absolute value function. Okay, so the absolute value function. Guess what? You're taking the absolute value of x. Surprise! All right, absolute value. Take the absolute value. So if you don't remember what the absolute value function looks like, or you don't know how to graph it, again, let's pick some x values and figure out what it is. Remember, absolute value is the distance from 0. So if I pick some x values, and then I want to know what the absolute value of x is, right, for my y, let's pick -3, -2, -1, just like in the last one, 0, 1, 2, 3. Okay. Absolute value of -3, +3. Absolute value of -2, +2. Absolute value of -1, +1. 0, 1, 2, 3. All right, so let's plot that. -3, +3. -2, +2. -1, +1. Sorry, that dot was a little off. 0, 0, 1, 1, 2, 2, 3, 3. Not a parabola. Okay, this is not the same thing as a square. This one, this is like two perfect lines. I can't do it with my hands. Two perfect lines makes a V. Bam, bam. And it's basically like this half is the identity function, and this half is the negative identity function, but flipped over the x-axis. Number 6, square root function. Guess what it has in it? Yeah, you're so smart. It has a square root. Yay! All right, so this is one of those problems that, or functions, that if you want to graph it and you pick ugly numbers as x, you're going to have really nasty numbers for y. So what I'd recommend is picking some smart values of x. Okay, so let's think about things that are nice, perfect squares. Okay, 1, 0, 4, 9, 16, 25, right? Those are all perfect squares. So I'd recommend using some of those. I'm going to make some space for the negative numbers later. But all right, so 0. Square root of 0 is just 0. Square root of 1 is just 1. Square root of 4, see I'm skipping 2 and 3 because the square root of 2 is like a really, really nasty number. It's irrational. Square root of 4 is 2. I'm going to jump to 9 because that'll be my next pretty one. Square root of 9 is 3. 16. Square root of 16 is 4. Okay, we could keep going. Let's plot those points first. So 0, 0, 1, 1, over 4 up 2. Okay, then we go over 9 and up 3, which is like way out here. So I'm going to like connect those dots first. Sorry, I guess that kind of interferes with our table. Okay, so what about negative numbers, right? -1, square root of -1. Well, you can't take the square root of a negative number, right? Because a negative times a negative is a positive, so there's no way that you could ever get two values that get you, when you multiply them together, that get you a negative number. Well, two values that are the same, right? Okay, so anyways, this is undefined. Undefined, right? So anything negative is not going to be on the graph, it's not going to be included in our table, and it's not in the domain. Okay, so keep that in mind with our square root function. So that is what our square root function looks like. That's it. Cube root function. Same thing. If I want to pick values of x that are smart for a cube root function, I need to think of what values are perfect cubes. Well, I know 0 is a perfect cube. I know 1 is a perfect cube because 1 times 1 times 1 equals 1. So 0, 1. 8 is a perfect cube because 2 times 2 times 2 is 8. So the cube root of 8 is 2. Anything past that will be off our graph. What about negative 1? Negative 1 times negative 1 times negative 1 equals negative 1. So cube root of negative 1 is negative 1. Same thing with negative 8. Negative 2 times negative 2 is positive 2 times another negative 2 is negative 8. So negative 2. And then you can plot those points. 0, 0, 1, 1, 8, 2. Okay, that's like way out here. Kind of looks like that. And then on the other side, negative 1, and negative 8, negative 2 is about down there. So looks kind of like the cube function, but like rotated a little bit. All right, next, number 8 is the reciprocal function. This one I'm not even going to go into the table. Again, this is just like memorization, and I'm sorry that I'm asking you to memorize something because I would much rather have you problem solve through things, but these are going to really help us in the future. So a reciprocal function ends up, and feel free to plot this on your graphing calculator and see what happens, or actually create a table. But basically, it never touches the x-axis or the y-axis. So that's the y-axis, this is the x-axis. So it never actually touches those. It gets closer and closer and closer and closer to the line, but never actually reaches it. So that actually brings up a good vocab word, okay? Side note, an asymptote. Weird name, I know, asymptote. But basically, long story short, this is a line that a function approaches. Yeah, so in this case, the x-axis is an asymptote, and the y-axis is another asymptote. All right, 2 more functions. All right, for an exponential function, number 9, there's a much longer story about it, but just for today, just so that you can see what it looks like, your basic function, depending on what b is, b has to be constant. So I'm going to graph 2 for you. Something that, if b is between 0 and 1, it's decay, and so it kind of looks like this. Has an asymptote of the x-axis, okay? And then in darker green, if b is larger than 1, then you have it facing the other direction. Okay, so that's your basic parent function, depending on what b is. So b greater than 1 would be like 2 to the x. B between 0 and 1 is like 1/2 to the x. Okay, 2 different functions, and so they look different. Last one's the logarithmic function, which again, don't worry about what it actually means or anything about it. Right now, just remember what it looks like. I'm sorry that this is what I'm asking you to do, but I promise it'll help in the future. Okay, I know it's hard to like bank on that and trust me, but I promise it'll help later. So the log function, log base b of x, goes through the point 1, 0, has an asymptote of the y-axis, and then kind of goes off to infinity as x gets bigger. All right, so what do you need to be able to do with these? Right this instant, except for 8 through 10, you need to make a table for them, graph them, know the equation in the graph, be able to identify them, which parent function is in a graph or in a function. Later, we'll be doing more stuff, transforming and actually understanding them, but for now, it's just like recognizing them, okay? So first example, identify the parent function. This one is obviously the square function. This one has a parent function, square root function. This one's parent function is the cube function. All right, last, look at these functions. Which one's the parent function? You got the square. the log, and the exponential. They're just transformed a little bit.